Alright, this is a lesson on exponents for grade 10. You did exponents in grade 8 and grade 9. So we're quickly going to revise the laws. So I have them here. Law 1 says when you're multiplying powers of the same base, you add the exponents, and you are given an example like that. 2 and 3 are not same base, so we cannot add the exponents. We're going to just multiply together. But look at this. X to the exponent 4. X here, if there's nothing, we know there's an invincible 1. So 4 plus 1 becomes 5. So I'm just going to write it down here. That's law 1. It says when we multiply powers of the same base, we add the exponents. So we're just going to add there. Number 2, when we're dividing powers of the same base, we subtract. This one is straightforward. When we are dividing, we minus the exponents. So y minus 4 becomes 3. So law number 2 says when we are dividing, as long as the bases are the same, we're going to subtract. And then law 2b is similar to that one. Let's go to law 3. Law 3 says when we have a power raised to another power, we multiply the exponents. So law 3 says if you see brackets, bracket means multiply the exponents together. And then law 4 says if we've got a product, we're going to distribute or multiply in with the exponent outside. So law 4 says if I have a product inside, I'm going to multiply. We know that all the here it's 1, 1. So I'm just going to multiply everything here by the exponent, which becomes that. Law 5, similar to law 4, it's the same thing, but with division. Okay, so if I say law 1, law 2, I'll be talking about these are the laws that you need to answer any question on exponents. Very important part of exponents. And then we've got two properties that I really love emphasizing. Property number 1, anything raised to the power of 0 becomes 1. And property number 2 says if we are given a negative exponent like this, we can write it as a fraction like this. If I have negative x as an exponent, this negative becomes 1 over a over x, meaning this whole thing becomes a denominator. You need to be able to move from here to there, and you need to be able to also move from there to there. So if I was given 2 minus 2, what would be, if they say write this as a positive exponent, I'm going to have 1 over 2 squared. The whole thing becomes positive, but as a denominator, which becomes what? 1 over 4. Does it make sense? And you need to be able to move from there to there. If we were given 1 over 4 and they say write it as an exponent, we're going to change the 4 to be a prime base. This is going to be 2 squared, and then this can be written, this becomes the base, and the exponent becomes negative now. I hope you get it. So these two properties are very important together with the laws that we are given. So let's do questions. Okay, I'm going to use this paper. Let's do questions now. I'm going to pick a few just for revision, and then we're going to do some cool stuff. So number 1, we're given 2p3 multiplied by p 282 Number 2, let's choose a question, x5 over x3. Number 3, x5 over x9. Number 4, x40, y16 over x36, y20. And lastly, let's choose this one, 3.24a. Okay, so I just chose random questions from this. It's just a bit of exercises that you can do. Okay, so this one, the question says simplify. The question will say simplify. So the first thing, what are we going to do? We're going to check, are these bases the same? Yes. Then we look at the exponents. So meaning this will be 2 squared. Remember, law 1 says when multipliers of parts of the same base, we add. And then this also, they're the same base, so I'm going to add P5. 3 plus 2 becomes 5, meaning my final answer will be P5. 4, P to the power of 5. Does it make sense? These are the same base, so I can add the exponents. This one I'm going to apply law number 2. So here I applied law 1. Here I'm going to apply law number 2. Law number 2 says if we are dividing, we are going to subtract the exponents. So what will be the answer here? 2. This is law number 2 of exponents. Nice. This is fairly easy, straightforward, nothing difficult there. Let's look at this question. When dividing parts of the same base, we divide. I'm going to divide again. What is 5 minus 4 becomes negative 4. Now, can we write this as a positive exponent? Yes. We spoke about it just now. We can write this as a positive exponent. So it's going to be 1 over x to the power 4. The whole thing becomes a denominator. Very important, very important. You must expect such a question. Even if they don't ask you in the test, always when you have this, try to make it a positive exponent by doing what I just did now. Number 4, we are given this. So we're going to look at the bases that are the same. So these two, the bases are the same. So are we dividing? Are we multiplying? We are dividing. So if we are dividing according to the laws of exponents, what we're going to do? Subtract. These two bases are also the same. So I'm going to subtract also. So I have 40 minus 36. If you're not sure, use a calculator. You're going to get 4. And then this one is 16 minus 20. The answer is a negative 4. Do you all agree? It's a negative 4. Then what did we say just now? How do we write this as a positive exponent? This is going to become a denominator with a positive exponent. This is a numerator. So I'm going to have x4 multiplied by 1 over y4, which becomes y4, x4, y4, like that. I hope you understand what we are trying to do there. Nothing hectic. We're just applying the laws of exponents. Let me write this one here. So here, what is the first thing that we're going to do? According to BODMAS, we are supposed to solve what's inside the bracket first. Solve what's inside the bracket. So I'm going to deal with the bracket before I deal with that square. So I can multiply 3 and 2. Do you all agree? 3 multiplied, remember this is a multiplication sign. 3 multiplied by 2 becomes how much? Becomes 6. So I have 6. And then I have a3, a to the power 3. I have a to the power 5. According to the laws of exponents, I'm going to add these two together. I'm going to add up the exponents, which becomes 3 plus 5 becomes 8. Do you all agree? And then underneath I have 12, A10B. all squared. Now, what am I going to do now? I'm going to try to simplify what's inside the bracket. I can simplify. If I press this on the calculator, 6 over 12 is going to become how much? Half. Let me just do it here so that you see. So 6 over 12 becomes 1 over 2. So this actually simplifies to 1 over 2. What about this one? 8 minus 10. 8 minus 10 becomes negative 2. So I've got a negative 2. If I want to write this as a positive exponent, I'm going to write it underneath. I hope I'm not losing anybody. Are we all together? So that's why I'm writing it underneath, because of I need to write it as a positive exponent. But what did I do? Laws of exponents, law number 2, I subtracted minus. And then the b is just there underneath, it's by itself, nothing much there. Then now I'm going to apply law number 4 or law number 5. I'm going to multiply in with the exponent now. I can do that now. So I'm going to say 1 squared is 1. 2 squared, it's 4. A squared multiplied by 2, it's A4. B multiplied by the exponent becomes B squared. So our answer is 1 over 4, A4, sorry, as a denominator, A squared, B squared. You can multiply in before you simplify, it works the same. But according to BODMAS, it's always easier to work inside. Boom! Yeah, to work inside the bracket before doing anything else. Moving along. Now, we have this new topic in grade 10 of changing numbers to prime bases. So changing to prime base. Changing to prime base. Something that the calculator does it for you. If you are given 16, 8, let's choose any number, 125. We can change this to prime base. In grade 8 and 9, it's a topic. You need to use the ladder method and until you get the prime basis of this. So prime base meaning the base has to be a prime number. I mean, it explains itself. The base must be a prime number. So all these numbers are not prime numbers. So we need to change them to prime bases before we can use them. So how do you do that? You say 16 equals, you press 16 equals sign, then you say shift, you set fact. Fact meaning factors. It will give you the prime factors here. So there, meaning 16 can be written as 2, 4. So in the test or in a question, if you are given 16, you need to change it first to this before you can use it. Let's look at 8. You say 8 equals sign, shift, fact. Then you get 2 to the 3. Let's look at 125, fact, 5, 3. So you can just use a calculator to make your life easy. They won't ask you to show your steps. This is grade 8 and 9. In grade 10, we assume that you know how to do it. You need to know how to apply it. So let me write 2 questions under this. Or let me put one more question. Yes, one more question. And then we move along. Moving along. They're given first this. And the question will say simplify. So what is the first thing? The first thing is to change all the bases to become prime bases. So I'm going to change the 9. How do I change the 9? 3 squared. Press that on the calculator, it will give you 3 squared. X, and then I have 2x there. Then what am I going to do there? I'm gonna load 3. When you see a bracket, means you must multiply. 2 multiplied by x becomes 2x. I have 2x there. So here I applied law 3. Now I'm going to apply law 1. When multiplying powers of the same base, we add the exponents. So I'm going to have 2x plus 2x, which will give me 4x. So my answer is 4x. This simplifies to 4x. I hope we are together. You can pause the video, you can rewind, take it back if you're not sure, if you are lost somewhere somehow. Let me do this one. What are we going to do there? Prime base. Yes, we're going to change all these numbers to become prime bases. Even if you're not sure if a number is a prime base or not, you can check it in the calculator using the method I showed you, and then check. So let's check 81. 81, you say equal sign, then you say shift facts, you get 3 to the power of 4. So in the place of 81, I'm going to substitute 3 to the exponent 4x multiplied by what? 27. I can also, I'm just doing this to show you. Then here, what are we going to do? When you see a bracket, bracket means what? You must multiply. So I'm going to multiply. 4 multiplied by this is 4x. Dot multiplication, this and this. Multiply 2, 3 multiplied by 2, it's 6x. Do we all agree? So here I changed to prime base. Here I applied law 3. And now I'm going to apply law 1. When multiplying powers of the same base, we add the exponents. So 4x plus 6x becomes 10x. Yebo. Yes. Okay. Any questions so far? No question. I hope we are still together. I'm going to do a last question here. Let me choose a nice one. Nice question. Okay, let's do this one. 2x 3 27. Can you all see? Over 8 3 2x 3x. So we remember in BODMAS we always start with the bracket. So I can go ahead and solve what's in the bracket. What am I going to do? I'm going to just multiply. This time this becomes 3x 27 8x 3 2 multiplied by x becomes 2x 3x. Step number 1. Step number 2, 2 and 3 are prime numbers. I have to deal with these people here to make them prime numbers. How do I do that? I press on the calculator. This will give me that. If you're not sure, use a calculator. And then this one will give me that. Can you all see what I've done? I haven't done anything new. I just changed the 27 and the 8 to be prime bases. Then I'm going to multiply in with the brackets, the x and the x there. Such that I have 3x on top, and at the bottom I have 3x 2x multiplied by 3x. Now what am I going to do here? I'm going to start by adding this one, because of I see the bases are the same, so I can add the exponents. So 2 3x dot 3x over 2 3x. Here I can add up the two exponents. It's going to become what? 2x plus x becomes 3x. Then here you can see, guys, that this It's going to cancel with that. This is going to cancel with that. The answer is 1. Or you can go the longer route of saying subtract the exponents. Can you all see? Subtract the exponents, and then this is going to be 0, 0. Anything to the exponent 0 is 1. 1 minus multiplied by 1 is 1. So either way, you do this 2, or this way, or that way, where you subtract the exponents, you apply law 2 to get a 0 there, it will give you the same thing. Is that clear, guys? Is that clear? Is that clear? Moving along. Now we are given interesting questions that we need to simplify with the knowledge that we have. So I'm going to do these questions. It's a bit of a high order questions, but same principles. I'm going to do this one. Yes. I'm choosing nice questions for you guys. Beautiful questions. Okay, I'll do this one. I'll do 15 also. If you need me to do more questions, you can let me know on the comment section. if I'll check it. Okay, let's go on. What is the first thing we're gonna do? Change to prime base. I can hear someone saying that. Change to prime base. So this one stays the same. 25 becomes 5 squared. X minus 1. Don't forget the x minus 1. Okay, moving along. Checking for a different pen. Okay, we'll stick with this one. 5 stays the same. We know there's a 1 there. 125 becomes what? 5 cubed x. So that's the first thing. You get a mark and a mark in the test for changing your numbers to prime bases. Now we have to deal with the bracket. Bracket means multiply. I mean, even if you didn't know it's law 3, whenever you see a bracket, you know that you're going to multiply. So in this case, we have 2 numbers outside of the bracket. We must multiply the 2 with the both numbers, not only with the x, such that I'm going to have x, 2x minus 2 over 5 and 3x. Does it make sense? Yeah, boo. You have to. A lot of people forget to multiply this with that one. You must multiply everything. Then here, what am I going to do? I'm going to add the ones on top. So I'm going to have 5x plus 2x minus 2. And at the bottom, can I do that also? 5, 1 plus 3x. What am I doing? Law 1. It says when multiplying parts of the same base, we add. So I'm just adding those 2 here. Can you see? X plus 2x minus 2. There you go there. And at the bottom, the bases happen to be the same also. I'm just adding the 2. So let's add the like terms. 1x plus 2x becomes 3x minus 2 over 5. I can just swap it and say x plus 1. 1 plus x and x plus 1 is the same thing. Then here, people, we are going to apply law 2 of exponents. Say subtract the exponents. Look at what I'm doing. If I'm subtracting the exponents, meaning I need to introduce a negative in front of this whole expression here. Because of everything here is going to be affected by the negative. Such that it's 3x minus 2 minus 3x minus 1. So if you are smart, or you can see, guys, I know you're smart. Yes, I believe in you. You are going to notice that when we subtract with the exponents, the sign changes. So if it's a positive at the bottom, when it goes up, it becomes a negative. So it's basically a change of sign. So I'm subtracting with these 2. Remember here, if it was 5a over 5b, it was going to be a minus b. Don't be confused because of now it's two terms. We are still applying the same rule of subtracting the exponents. And we all clear. This and this is going to cancel. And then I happen to have a negative 2 and a negative 1 there. So my answer will be a negative 1 over 3, which becomes negative that, which becomes 1 over 2, 5. I hope you get it. I hope you are following what has been done there. Nothing hectic, honestly. I'm just doing all the steps. That's why it looks a bit long. You can pause this question, do it again yourself, and check if you get the same answers. Let me do the last question in this section. Yay, boo! I hope you can see. This is X. Okay. Can you all see? Let me try to focus the video. Is it clear? So what are we going to do? Change all this to prime base. So 18 becomes 2, 3 squared. 2, 3 squared. I'm going to multiply this by x. And then 8, that becomes over. That becomes that. X plus 1. That becomes that. 2x minus 1. I did not do anything. Okay, I did something, but I didn't do much. It was just to change this one. Change this one. Change this one. Can you all see? I'm just changing all those numbers to become prime bases. Nothing new. Nothing different. Then what do? We multiply in everywhere. So this becomes that. This becomes that. It's a 2, 3x minus 3. And that becomes that. That becomes that. That becomes that. That becomes that. Did I do anything that you don't know? No. I've done everything that you should know by now, just to multiply in. So here, look, it's 2x minus 2. So the 2 squared, 2 multiplied by 2x becomes 4x. 2 multiplied by 1, it becomes 2. And I'm going to add the like terms on top. X plus 3x becomes 4x minus 3. I can skip steps now because I want to believe that you are following. This is multiplication, commutative law. Oh, okay, sorry about that. Okay, then commutative law, I can pause this, I can move this. 4x minus 2 and 3, 2x plus 2. So that I'm going to subtract here. 4x minus 3 minus 4x, it's a negative. If I subtract, a negative becomes a positive. Do you see it? And then 2x minus 2x minus 2, because I'm subtracting this by that. So this and this goes away, this becomes minus 1. This and this goes away, this becomes minus 2. Then I have minus 2 multiplied by minus 3 squared. Minus 2 multiplied by minus 1 over 9. 1 over 2 multiplied by 1 over 9 becomes 1 over 18. Yes. Okay. Moving along, guys. Moving along. Okay, let's move along. So this part that's the third part, third section of factorization. You need to be able to factorize exponents. So let me go through this example. Once you see a plus or a minus, so far what we've been doing, there was no plus or minus in between. It was just multiplication. Can you see? It was just multiplication. But once we have this, a plus or a minus in between, you know that you are going to do what? Factorize. All the time. And then how do you deal with that? You are going to break this down. Remember, if you are given this, what was it going to be? A log 1 of exponent multiplying parts of the same base. It was going to be base, one base, and then you're going to add the exponents. Are we all clear? So this is log 1. Exponential notation, expanded notation, or it's a reverse of log 1. Whatever what you want to call it. So if you are given this, expand. If you are given this, for you to be able to take out a common factor, you have to expand it. You have to write it in this form, where each exponent has a base. And once you have written like this, there we go, there we go. We take out a common factor on both the terms, which is 3x. 3x goes out. And whatever that's inside the bracket, I always say, do what? Press it on the calculator. You put together what is left in the bracket, and you calculate it. This is going to cancel with that. This and this is going to cancel out. This and this is going to cancel out, so that you're left with 21 over 7, which is 3. Are we all clear? So this is exponential equation, exponential expressions involving factorization. Okay, moving along. So I'm going to do a few. Can I do just 3 because of time? I'm going to do 3 of the questions, and then we move along to other exponential equations. This is the nice part. Imagine that. Okay, now let's go on. Let's go on. Let's go on. I'm going to choose 3 questions there. Starting with this one. Plus, I know that I'm going to expand. So, let's look at this question. So I'm going to expand this one to, do you all agree? Every exponent is going to have a base. This one, 3x dot 32. Just like that. Here, do I have to change this to a prime base? Not really, because of there's no exponent on it. So let's leave it as it is. Focus on the ones that have got an exponent, especially an unknown, an x or a variable. This one, I'm going to break it down also. I'm going to expand everywhere. Then on top, do I have a common factor? Yes. In both these terms, I've got this. I'm going to take this out. What am I left with? And at the bottom, I'm left with that. Now, what's inside the bracket? We are going to press it on the calculator as it is. This and this is going to cancel out. 9 plus 3 is 12. 12, oh guys, 12 multiplied by that is 24. This becomes 1 over 2. Okay, let's go on. Which question can I do here? I'm going to do this one and this one. Is it fine? Okay, let me copy it down. 4x plus 3, 2x plus 1 over 7, 2x plus 1. Okay, so This question is a nice question because it puts in a lot of things that we need to do. We need to make sure, especially this type of expressions, the one with an exponent on top, that it is a prime base before we do anything. So I can just go ahead and write it as a prime base, and I know it's going to multiply with the x. Plus 3, 2x plus 1 over 7, 2x plus 1. Okay, here it's a 2x, sorry. There's a 2x there. And at the bottom there's a 2x. I didn't copy this question correctly. You see there's a 2x, there's a 2x there. So I need to put a question, a 2 there. Okay, then what am I going to do? I'm going to write this one as it is. Expand here. 2x become and that. I'm going to expand this. Each will have a denominator like that. Over 7, 2x and 1. I'm going to also expand that. Take out a common factor on top. 2x. 1 plus this and that goes away. I'm left with what in this case? 2 like that. Over 7, 2, 2x and 2, 1. This and this goes away. 3 times 2 is 6. 6 plus 1 is 7. 7 multiplied by 2 is 14. So this becomes a half. Wonderful. Nice, beautiful question. Straightforward. I'm going to do the last one. Can I do it here so that I save paper? I need to save paper. The question is as follows. This is the question. 2.3x plus 3x minus 2 over 5x plus 1 minus x minus 1. So what do we do here? This stays the same. Plus, here I'm going to expand. When I expand, it becomes what? 3x dot 3 minus 2 over 5. Expand also here. Sorry about that. Is it a 2? Yeah. Okay. Interesting question. Let's do it. 7, 3 minus 1. Okay, so in this case, what are we going to do? Do we have a common factor on top? Yes, we have a common factor on top. So I'm going to take out a common factor. It's 3x. 3x goes out. I'm left with 2 plus 3 minus 2 over. At the bottom, do I have a common factor? No. I do not have a common factor at the bottom. I do not have a common factor. Okay, there's no common factor at the bottom. What do we do? I'm going to write it as it is. 2x, 2, 1 minus 7, 3x, 3 minus 1. And then let's solve this part on top. 3x, this becomes 3 plus 1 over 3 squared, which is 1 over 9. So this is going to become 2 plus 1 over 9, which is 19 over 9. Over, at the bottom, is there any common factor? There is no common factor. For now, the most I see that I can do is to multiply these two together. Maybe I can have this 2x, and then here this becomes over 1. Remember, it's a negative 1 there, so it becomes 7 over 3 multiplied by 3x. I don't know if there's anything further that I can do there. Please check. Maybe let me know on the comment section if there's something you see. I can't cancel that because this is one thing. I cannot cancel this. I can only cancel it if it's outside the bracket or if there was no minus here. Here I was supposed to maybe factorize something. Yeah, so please check it and then let me know if there's any step I can do, but so far I don't see anywhere I can go there. Okay, moving along. Exponential equations. Exponential equations, remember, in grade 9 you must have done it. The rule says, let's do an example now. Exponential equations. Let's say we are given something like this, and the question says solve for x. Oh, that's a big question. No, bad question. Let's do something like this. We're given a question like this, and the question will say solve for x. Okay, if you are to solve for this, the first thing you need to do, change the 9 to become a prime base. So you see, any question involving exponents at this point needs you to be able to be familiar with prime base. So the prime base of 9 is what? 3 squared. Once the bases are the same, we can drop the bases and equate the exponent. So if I can drop the bases, I equate the exponent becomes the whole number, becomes 2. So step 1, change to prime base. And then so your aim is to get the bases are the same. Once the bases are the same, we can drop the bases and equate the exponents as they are. Okay, so let's do questions straight away. Let's do some few questions. I'm going to choose from all of these questions, and then we solve. So solve the following questions. I'm going to choose maybe 2 from here, 2 from there, and 2 from there, and then we solve them. Okay, let's go on. So remember, the aim is to get these 3 steps right. So the first question is 7. 4x equals to 49. So I'm going to change the 49 to become a prime base. 4x equals to 7 squared. If the bases are the same, we can equate. I can equate. Drop the bases and equate. Divide by 4, divide by 4, meaning x is a half. It's a half. And you can actually, with exponents, equations is nice because you can always check your answer if it's right. So I'm going to substitute a half in the place of x here, and it should give me 49. Can you see? So you can actually check your answer and verify. Let me do this question, number 2. 8x multiplied by 2 equals to 128. So the idea here is to always get rid of this number without an x, and then isolate this one. In the same instance, if we were given 2 equals to 4, 2x equals to 4, we always divide by 2. Why? We want to isolate this one. So the same principle applies here. I'm going to divide both sides by 2 by 2. This side it cancels. I'm left with 8 to the power x. That side, half of 128 is 64. And if I can get it in this case, 8x, I know it's 8 squared. 8 squared will give me 84. So I don't have to really change to prime base. You can change to prime base, but if you can see it, that 8 squared will give me 84, meaning the value of x is 2. Can you all see it? You might have used another method where you have to change both of the numbers to prime bases. Let's check and see. So in this case, I will have a 2, 3, x. 64 becomes what? 2 to 6. 2 to the power of 6. Multiply the 2. And then the bases are the same. Drop the bases. Divide by 2, divide by 2. So divide by 3 on both sides. X will be 2 because 3 goes into 6 2 times. So either method, you would have still gotten your answer as it is. Okay, moving along, guys. Moving along. We're covering everything on exponents. This is also important information for the grade 11s, because of grade 11s we assume that you know this information. So these are a bit of high order questions that you can also apply and you can be tested in grade 11. So I would advise also grade 11s to tune in. Okay, let's look at a question like this. We did say in the first part of this video that you can change this to be a negative exponent. So firstly, let me change everything to be a prime base. I can change this to be a prime base like that. Then I can make it a negative exponent if I do this. Do you all agree? Do you all agree that I can write this as a negative exponent? Yes, based on those principles that I showed you in the beginning. Bracket means multiply. I'm going to multiply this together. 2 multiplied by that becomes 4. Bases are the same. I can now equate the exponents. Exponents divided by negative 2 on both sides. X is a negative 2. Is that clear, guys? Clear, straightforward. Maybe let me do last question on this part. I don't know what question is that, what number. I'm gonna do this one, and which other one can I do? Maybe this one. Yes. Okay. Now here, what are we gonna do? We're gonna change this to a negative exponent. Becomes negative 1 x. This changed to a prime base becomes 3, 3. I can change this also to be a negative exponent. Do you all agree? Like this. This one I can make it like that, multiply parts of the same base, so I can equate the exponents. Negative x equals to negative 3 divided by negative 1 divided by negative 1. X is a positive 3. You can check the answer and put it there in the test, in the equation. Let's look at this one. 3x. 3x squared, x minus 1. This becomes that. And then here, 2x minus 2 equals to 3, 4. Here I'm going to apply laws of exponent. Can you see? Law 1. I'm going to add these two together, such that I have 3x minus 2 equals to 4. If the bases are the same, I'm going to equate the exponents. So I'm going to have this. I took the exponents because the bases are the same. Take this negative 2, it's a negative. If it goes that side, it becomes a positive. So I have 3x equals to 4 plus 2, which is 3x equals to 6. Divide both sides by 3, x is a 2. Are we all clear, guys? Are we all clear? We're almost there. We're almost hitting 1 hour. Yeah, bro. Let's go on. Any other question? You can choose. You can pick any question and we can do together. This one here, you can do it. We're going to take out a common factor and then see where it leads us. I want us to try this one. Okay. Remember, if there's a plus in between, we know that somewhere, somehow, we're going to factorize. So we need to expand. This becomes, do you all agree, guys? 2, 4, 3. My common factor is there. Then what am I left with if I remove this? 2 multiplied by 3, I'm left with 6 plus 3. 2, 4, 3. 2x, 9. Divide both sides by 9. Hey, 2, 4, 3 divided by 9, we get 27, yeah. It makes sense now. 27. Okay. And blah, 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 blah. Guys, let's move on, let's move on, let's move on. Oh, actually we're done. We're done. The only last part is rationalizing. Rationalizing, I'm going to put it here. How to rationalize exponents. Say we are given 1 over 2 equals to 5. You are told to solve this question. At this point, what are we going to do? We multiply by the reciprocal of the fraction. So reciprocal means if you are given 1 over 2, the reciprocal, reciprocal, whatever, becomes 2 over 1. Ne? Yeah, so that will become 2 over 1, 2 over 1. So that this cancels and we only left with 1. So the idea of rationalizing, we call it rationalizing. Oh my God. Something like that. Rationalize is to getting x to have an exponent 1. So the only way that we can have an exponent 1 if we can multiply by the reciprocal of this one. So that this 2 gives us 1. And then in this case, in the other side, it multiplies. So when numerator 2 multiplied by 2, 1 multiplied by 2, it's 2 over 1. So the answer is 2. Meaning in this case, x is 5. 5. This is actually a square root. The square root that will give us a 5 is what? 25 will give us a 5. That's why we have a 5 there. Moving along, let's rationalize just a few guys, just a few. I'm going to do this one. 3 over 2 equals to 27, and then 3x 5 equals to 729. And then we're done. We are done. Oh, thank you for watching. So this, we change it to a prime base. Then we rationalize 3 over 2, so I'm going to multiply it by what? 2 over 3 on both sides. 2 over 3. This and this goes away. This, if you're not sure, you press it on a calculator like this. Multiply the exponents together. You get it 2. Can you see? Or you can see that 3 and 3 cancels and we are left with what? 3 squared, which is 9. So multiply the exponents together. Low 3. Oh, what do we do here? First, get rid of the 3. Get rid of the 3. 243. Make this a prime base. 3, 5. 5. So in this case, we can do the same thing. If the bases are the same, we drop the bases, equate the exponents. But if the exponents are the same, we can drop the exponents and equate the bases. So meaning x is 3. Voila, 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 voila. Thank you guys. Thank you for watching. If you have any question, you can ask. If maybe I did something wrong, you can ask. This is just a full summary on exponents for grade 10 and grade 11. Can I fix that? Grade 10 and 11. Because what we have done, they mostly ask it in grade 11. So if you can master this in grade 10, you are on your road to success. Thank you.